Good afternoon. Welcome. Great to have you here, joining us for the SurrealDB stream number 30. Today we're going to be looking at everything to do with graph, querying, record references, optimization, shortest path, you name it. If it's got to do with graph, then we'll be talking about it. We're going to be answering as many questions as there are as well on from YouTube or from LinkedIn. I'm not sure questions come in from X, but by all means share your questions there, and we'll be looking for them. So yeah, welcome. Well, I'm joined today by Alexander and Misha, and we're going to be discussing graphs. So they're going to be demoing a few of the things that you can do with the exciting functionality that we got built in early this year and towards the end of last year around graphs. So Alex, Misha, I think the first question on people's minds is, what can you do with graphs? And then from there, and also actually before we go to the next question, why are graphs so powerful? Because most people use relational databases or document databases, but actually the more I hear about developers who are introduced to graphs, their mind is blown with the possibilities of what you can do with it. And more we're seeing organizations and enterprises move to graph as a way of analyzing data. So why is modeling data in a graph-like way better? And what can it enable you to do?
Yeah, so I think it's a really interesting question, because effectively when you look at the earliest databases, they were essentially network databases. So in a sense, when people were deciding in the beginning, how do we actually make data relationships, they kind of thought of, oh, what's the most natural? It's most natural to think in terms of networks or graphs and kind of like think in things related to other things. You don't really think of things as like, oh, person one joins on table person two. You think like person one knows person two, or like person John knows person Bob. And what happened was that like the network model wasn't necessarily the right approach because it was too inflexible. And then you kind of like had the relational model that allowed for much more flexibility in relations. But then we kind of like have the resurgence of the graph. And now we kind of like are at the point where graph is becoming more and more popular as more and more people are exposed to what you can do with it. And as we are kind of like seeing, even with AI kind of like taking off, we're seeing that like one of the best ways to actually model information for AI is using knowledge graphs. So essentially connecting information together in a graph so that AI can actually understand it. And so that's kind of like where a brief history of kind of like where kind of like this idea of graph came from, and kind of like this resurgence in it, and particularly when it comes to AI, as it is a very natural thing to model.
The way I've always described it when I'm talking to people is, we think of things in terms of types and collections. So that makes sense from a tabular perspective or a document database collection perspective. But actually, in our minds, things relate to other people in a graph-like way. And that is, so if you bring those two concepts together, if you bring tables, so an animal, a user, a person, or even dogs and cats, those are types. But they connect to other people through relationships. So the person owns a dog, the person loves the dog. And that is actually the best way of modeling. If you can bring those two different ways of modeling data together. And that leads to the kind of best way of visualizing data in the way that your brain actually thinks about data in terms of the relationships and the networks. Now, in SurrealDB, for a while now, we've had graph relationships, the ability to create a full graph relationships, which is bidirectional and can be traveled both ways. But new functionality we've just built in, and thanks to Misha for building this amazing new functionality in, is something called record references. So, Misha, what is the difference between record references? Why would someone use it? And then we'll give a bit of a demonstration today before we jump onto other aspects of the graph.
So I think one of the main things which record references offer is referential integrity, right? So in SurrealDB, you can have basically a document is tied to a record ID, which allows you to do a lookup to the document very quickly. And let's say previously that you had a blog maybe with a couple of tags. You could put those tags on a blog, and you could very easily look up those tags based on a blog record. but there wasn't really a link back from tags back into that blog post. And you need to use an index to make those lookups quick again, for example. And you would need to use events to add in this referential integrity, which it just wasn't a very nice way of doing things. Now, what we did in the latest update is that we added in record references, and essentially what this does is it adds in a backlink, just like it works for graph relationships under the hood. It creates a backlink from that blog post, from that blog post back to the tag, which allows you to do a very quick, efficient, and easy lookup. And in addition to that, it allows you to, with just a couple of keywords, add in referential integrity or automatically clean up references and all of those nice functionalities.
So I don't want to spend too long on this, because obviously we touched on this on the previous stream, but I think it's worth mentioning again and showing again before we dive into some of the more complex aspects of graph. So Misha, let's bring up your screen and let's just show a couple of things that you can do with record references and why it might be a valid choice for using these in optimized circumstances where performance is key and you don't need the full metadata information of a graph edge.
Yeah. Let's see if we can get the screen up there. There we go. So here, first of all, we've got this table tag, just like I said, and we can create a couple of tags like tag SurrealDB and tag multi-model. Then in addition, we'll have this post table. We'll have a field called tags on the post with a type of array record, which point back to those tags. But in addition, what's new in 2.2 is we can add this reference keyword, and that will create that link under the hood back from post to the tag record ID. And then lastly, we can add this onDelete onSet clause, or there are a couple of other keywords here, but we'll go with onSet for now, which will basically remove this tag from the array once this tag is actually removed. So if we just run this query where we create this post about SurrealDB, we can see that we've got these tags here. And let's quickly see. So if we do post SurrealDB .tags.star, we can see that, we get those. Actually, it should be double star, I believe. Yeah, we can fetch those records quite easily here. Now, previously, what you would need to do is you would need to, for example, select everything from tag, and then we want to get, let's see, select everything from post where tags includes.
So you now have to build an index on that table in order to search backwards in a way, right?
Yeah, you need to do something like this, where now you can see for tag multimodal we can find that post back, and for tag SurrealDB we can also find that post back. But what we can do now, much more easily, is we can say for tag SurrealDB we can get the references. We can just get all the references. In this case, we can also filter there. But you can see that we quite easily now get that post of SurrealDB back. It's very efficient. It's a very fast lookup without using any indexes or anything. And as I said previously, the added nice benefit of this is if we now delete this tag SurrealDB, for example, let's run that, and we select everything from post, we should now see that the tag SurrealDB is removed. In addition, some other possibilities there is to reject and delete. If this tag is still referenced here, we can just do nothing with it. And let me quickly look what the other options there are, because I do not recall at the moment.
Cascade, reject, and do nothing, or remove. Yeah. Yeah.
So yeah, Cascade is the other big one. Basically, with Cascade, if we were to delete this tag SurrealDB, then the entire post will be deleted.
Cool. So that's record references. We touched on those in the past. Jump into our documentation to see a little bit about that. But today we're going to be talking about graph edge relationships. And these are full graph relationships where you can put metadata on the joining node, as it were, the edge, the relationship. And that will lead us into the other things that we're talking about today. we're going to be looking at depth first graph traversal, and we're looking at the recursive querying functionality that you can then do with that. So you can actually traverse round and round and round until you find the node that you need. We're going to be looking at how to output graph traversals as trees. This is an amazing piece of functionality that very, very few databases, if any, have, that enables you to visualize your graph in a different way. And then you can now also compute directed and shortest path between nodes, and we'll be showing you how to do that. So let's start with the most basic example we're going to be talking about today. Misha, let's start with you. Looking at effectively graph traversal, and we'll be slowly building over time. So graph relationships as a whole, being able to say, look, I am a person and I have bought a product. So bought is the relationship, the product is the third node, as it were, or the second node. How would you model that in SurrealDB? And then how would you go a step further to be able to add recursion in, to be able to find nodes that are required in your query?
So let's craft up a little example here. So we'll have a person, right? We'll have create person Tobie, and we'll also have person Alex, and we'll have person Misha. Then let's create some products in here. So let's say product shirt, product sticker, and that should be fine. Let's relate. Let's say that person Tobie bought product shirt. There we go. And let's create a couple more. So let's say that Alex also bought a shirt. Let's see what we want here. So we want to have Alex also buying a sticker maybe. And then I guess, Alex will buy a sticker. I guess I'll buy a sticker as well. Let's see if we can create a nice, meaningful example out of this. So we can query, select, we can go from person Tobie. We can see what he bought. So let's say selecting from person Tobie bought. Right. I'm not sure why that ran so often now. Let's just create a new database quickly here. Run that again. That's better. Okay, yeah. So we can see that person Tobie bought that shirt. Now maybe what we want to do is that we want to see other people who bought that shirt. Oh, no, I did it again. Sorry. Let's just do another quick rewind there. Oh yeah, so who bought the product, and then that was also bought by another person, and then we should get Alex and Tobie. And maybe in there we can go out again into person who bought something like another product, and then we should be able to find sticker shirt 2 times, because Tobie bought a shirt, Alex bought a shirt, and Alex also bought a sticker. Now this query gets quite long right now.
So just to reiterate over this, right now you can build out your query exactly as you want, but you have to manually build up the relationships between the nodes as you know that they exist in order to get to the final product. So here we know that person Tobie is a starting point, and we want to get products that we want to recommend to that user, but I have to work manually through those different relationships to get there. And that's fine. For many queries, that's exactly what you want to be doing. But sometimes you don't necessarily know the depth to those nodes, or you might not know the exact path, or you might need to recurse. And that's the main point about what we're talking about, right?
Yeah. I think because we go both ways here, the examples will get a little bit lengthy. So I'm just going to move over here quickly to this other example from the docs, actually, which is a little bit easier to follow just for demonstration purposes. You can make it as complex as you want, obviously, but just for demonstration purposes, we'll go here. So let's see, we've got a planet Earth, we've got a country for US and Canada, we have some states and provinces in those countries, and then we've got some cities in those states and provinces. This is basically, you can see it like we're going down, 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 down. We can create some relationships between all of these different record IDs. So in this example, we're creating relationships both for record IDs and for graph relationships, as you can see here. And we're doing that, we're nesting that down basically everywhere.
And importantly, the has and next is always going to the right. So we're using that same relationship, traversing in a single direction in this particular example.
Yeah. So we can just run that quickly and we'll get all of this data populated here. Now with record links, you would just create like this, for example. You could, we can get the next as the countries, we can get next.next as the state provinces. So that's the countries and then the state provinces. We can go next.next.next as the cities. And while we get the result that we want, it gets a little bit complex. And same with graph. We can get has country as countries, has country and has both provinces and states as state provinces. And we can get we can go any depth, but it gets quite complex to write these queries and quite complex to follow.
Yeah.
Now, with just a little bit.
That brings us on to the arbitrary depth queries.
Yeah. So this is a new syntax. We're starting from planet Earth. Then this is basically the syntax which indicates a recursive query part. So in this case, we're going to be going 2 steps down the record links at the next field. So if we run that, we can see, as expected, we go from planet Earth. We get the countries first, and then we go again, we get these next again, and then we get the states and provinces. And the same counts for the graph queries.
So importantly, you can actually do this not just on graph edges and relationships, you can do this on traditional record links, and if you're using record references as well, you can do that in that way as well.
And actually any type of data, as long as it recurses down, you can use this syntax to essentially map over that recursive data and get the result that you need.
I'm going to ask you a question in a minute, which is, what if some of those fields, if in terms of a record link, are in a nested field inside a record? But let's come to that in a minute. So, So let's carry on through this example.
Yeah, we can also do this at any depth. So we can say, I want to recurse at least 1 time, but up to 3 times, and then we get the name at the end. And now we can see that we get Canada and US. I think actually my...
Yeah. So brackets matter, I think, is the most important thing here.
Yeah, I was just looking at this example. I was like, doesn't make sense. But yeah, so let's quickly have a look at that as well. So basically, after a graph part, what you can do is you can specify these brackets. And that's basically to make sure that you can contain what part of the idiom chain will be recursed. So without these brackets, all of this will be recursed. So then once we get to these countries,
it gets stuck and can't go any further.
We can't go any further because we cannot look up a graph relation on a string, for example.
Yeah.
Now, if we put these brackets here, though, which we can use to contain the graph lookup specifically, we now first, if we just run this, we first iterate over these graph relations recursively, and then at the end, we can still do the .name lookup afterwards.
So effectively, this is the ability to repeat a particular query as many times as you want.
Yep.
From either 1 to many, or there's actually the ability to do it any amount of times. Is that correct?
Yep. If you just specify 2 dots, it will go from 1 time to, I think the limit right now is in 200 recursions or something, but that's probably not something you'll reach, and that's actually customizable as well.
Okay, awesome. So effectively you can then build up repetitive patterns inside this query to be able to arbitrarily search for effectively matching paths deeper down the query as you go, right?
Yeah, exactly.
Amazing.
I think one last thing to show here, and there's a lot to uncover, obviously, but is recursive trees, which is also possible with the syntax. So in 2.0, what we did is we introduced the syntax, which you can use to destructure an object. So let's give A1 and B2, just for this quick example. We can destructure just property A from that object. And when we do that, you can see that we get just A. And that syntax, we were like, we can do something with that and recursion. It's actually quite cool if we can generate recursive trees as well, which is what we can do with this destructuring. So what we can do here is we can go from planet Earth, we can go between 1 and 2 times, we can recurse that many times. And then at each depth, we basically want to get the name, we want to get the ID, and then we want to repeat this pattern, and the @ symbol here basically symbolizes this whole section. So it's like we're going in there, and then eventually we sort of escape what we're doing. We go out again, and we repeat that pattern again. If we run that, we can see that we first start with planet Earth. So from planet Earth, we get name, ID, and we get contains. That's when we go from planet Earth again, and we look up the has and then whatever it contains. And then we can see we get the countries Canada and US, and we get the contains with the provinces and with the states. Now we can also do this up to 4 times, up to a depth of 4 times, for example. And then we can go into cities even and basically recurse all the way down and generate a recursive tree that way. One thing that I had in mind there when building this is, like, for example, in Notion, you've got the sidebar, or maybe just in like a file explorer where you can go and get this recursive tree structure of all your files and folders. And I think it's a pretty cool feature to have.
Importantly, though, you don't have to store your data in one big record, right?
Exactly,
That's really where the power of graph comes. Alex, let's talk a little bit about the use cases of arbitrary depth, recursion, and also hierarchical trees, because this can be applied to so many different areas. Isn't that correct?
Oh, no, absolutely. So in terms of like when you're using these kinds of things, one of the ways is basically like simplifying join structure. So for example, if you wanted to do a recursion with like normal kind of like SQL, you would have to do like with recursive, and then you kind of like are kind of thinking very differently about it. But in a graph like structure, you're thinking in the same space as you kind of like visualizing it. And so like in your mind, you kind of like are seeing the same thing as you're essentially putting in the code, and kind of like in a similar way where you would kind of like code it in an actual programming language. But the use cases for kind of like in kind of like commercially is about kind of like community analysis. It is about being able to more easily kind of like see relationships between disparate things. And that's kind of what we'll showcase a little bit later, the difference between kind of seeing it visually and seeing the data, and kind of like how powerful that can be. But there is a lot of kind of research around, like when it comes to medical, like analyzing communities, or say, for example, when the COVID epidemic broke out, the way you would kind of like analyze super spreaders is effectively using a graph. And so you see kind of like the people and which people are connected to which other people, and then you kind of like recursively go through that chain to basically like see how the kind of like disease spreads. And so that's like one aspect. And so a lot of other aspects in the medical field that make use of graphs. Another aspect is in terms of like financial services in fraud detection. So would use graphs as well to basically like have these clusters which you would see in the graph and see that like, oh, if you have a payment that is kind of like outside of any connection, you kind of can flag that as something suspicious, because you have all this kind of connected activity which is grouped around this particular thing, and then all of a sudden you have a disconnected node, and then it's like, oh, like what's going on here? And
so that's effectively, you're talking about pattern detection, analysis, and matching as well in a way, aren't you?
Yep, absolutely. And interestingly enough, a lot of kind of like machine learning algorithms can be expressed as graph problems. So essentially, when it comes to figuring out the kind of like shortest path to thing, or like the likelihood of things, you can actually find that through kind of like how close they are on a graph. And so that's kind of like two like really big use cases, like one in kind of like medical space, one in kind of like financial services space, or these kinds of like pattern detections.
I mean, you mentioned a few industries, as it were, but artificial intelligence is another big one, right? Being able to detect and analyze more from your data. Defense is another one, constantly trying to analyze massive graphs of related, interconnected data, but also, as you said, maybe not necessarily related, and trying to analyze the patterns that aren't necessarily immediately visible. That's really an important point of what you can do with the recursion, with the arbitrary depth, and with the hierarchical trees. Visualizing your data. We'll talk about actually visualizing your data next stream, but actually visualizing your data in code in a much more efficient and kind of improved way.
Yeah, so we see Ayman posted, he used it for train networks and finding the routes to take. And then there is kind of like this problem called the traveling salesman problem, which is basically like, how do I find the optimal route? And graphs essentially allow you to kind of like figure that out. So you have these essentially recursions of where you're testing kind of like the different routes of like, oh, what if I do this? And then like, what if I do that? And so you essentially can find the optimal route for like logistics to kind of like tell people to like, oh yeah, like we have analyzed it. And then like we found that like once we kind of like looked through the graph, we found that this was actually the optimal route to take.
Awesome. So I'm going to just jump into the community questions here for a second. So, Ayman, great to have you here. I think I've got a question at the bottom, but yeah, as Alex said, you use it to train networks and finding routes to take, definitely. V Sig, hi, great to have you with us. And Louis Novo, also great to have you with us. Now, you've got a question there. When will references be available to SurrealDB cloud users? So we've got a big update coming to the cloud, which will enable you to be able to specify the capabilities that you want enabled on your instance, and that will enable you to enable references and other functionality as well. So that's going to be coming really soon. We're really excited about this release. It's got a great user interface improvement. So very soon, very soon. Seeing the Forest, great to have you here. Good question. So Seeing the Forest says, would it be imprudent to define both record references and graph links between the same data tables and fields? Graphs are powerful, but they're much less performant for big queries. So this is an interesting one, isn't it? Because the cost of graphs is in the amount of data that it has to create in order to create this kind of middle edge that can store metadata. What do you think? Do you think there's a possibility of using both to actually improve the performance? Because you're still going to have a cost potentially in the storage, but if you want to query things in a more performant way, then that could be beneficial.
Yeah. So let's see. For graph lookup, we first do the edge out, which is one lookup. Then there's not. So it's basically record reference would be half of the reads, as long as you don't read the record of the middle node, or like the edge node. As long as you don't select that record, it's basically half the cost to use record references.
There's also the fact that the record reference, if you're going, let's say you're going from a record reference directly to a node, and you've also got a graph relationship in between, the record reference effectively, if that node already exists, it's actually just two writes. It's the update for the node and it's the write of the reference. Whereas the graph has the edge and it has 4 nodes in between. So it's effectively so 4 relationships in between. So it's effectively 5 writes compared to, or 5 writes and an update potentially compared to 1 write and an update.
Yeah.
So seeing the forest is a great question. You can definitely use both. I think that's the beautiful point of SurrealDB, the fact that you've got the flexibility to do what you want in your queries. And yeah, it's a great point. It probably is. It's definitely possible to use both, and it's probably beneficial to use both depending on the type of query you want to operate in the long term.
I think graph is especially easy to make sense of your queries, as it's really you can read them in a very idiomatic way. I think you can achieve that with record links as well. The important thing about graphs, obviously, is that on the edges you can actually store metadata. So, for example, someone ordered a product, and you can put metadata on when the order was made, what the shipping address would be, all those kind of information points. You can put that on that graph edge essentially, which is I think quite unique as well about SurrealDB. And you cannot do that with record reference.
So it's actually the combination of a lot of things, because effectively what record references allow you to do is basically like have like the foreign key constraints of your typical like SQL database, but it's essentially combining that with graphs. So you can have like, some part of it being a kind of like full like triple graph, as in like person, order, product, but then you can have kind of like the order basically being a record reference to something else. And so in your kind of like query, you can make use of both the kind of like arrow and dot syntax. So that allows you to have the flexibility to kind of like do it exactly the way you want it without being constrained by, I was like, oh, this needs to be a certain way, or like it's either or. So instead of having to choose between record references and graph, you can essentially mix and match to basically create a data model that makes the most sense for you.
Awesome, yeah, definitely. Before we jump into some more examples, Luke Skinner, great to have you with us joining us from Perth, Australia right now. Glad you like the sticker. Show it off on the front of your laptop. I know Misha's got hundreds on his. So let's jump into the end of hierarchical trees. I know, Alex, you had an example on this, didn't you? So let's jump into your screen.
Yep. All right. So I'm sharing my screen now. So we have here what looks like a fairly complex example, but it is, once we kind of like visualize it, you will see how kind of simple it can actually be. So we're essentially creating a hierarchy, and here we're creating a organizational hierarchy, starting with the CEO. Then we will have VPs, and we're creating 3 VPs. And then we have managers, we're creating 3 managers. And then we have employees, and we'll create 3 employees. And what we're essentially doing here is we're kind of like looping through it, adding relationships, looping through it, adding relationships. And then we're kind of doing this select query here. And then once we kind of select it, we can see that we have kind of gotten all these relationships. And again, you can like look through it like this, or you could look through it, for example, in a table. But that might not be the kind of like optimal way of viewing this hierarchical data. And that's kind of why the graph visualization comes in. And now all of a sudden, it makes perfect sense, where you have the CEO, then you have the VPs, and then you have the employees all grouped together.
And that's powerful, right? Because the hierarchical tree is a great way of taking a result, which for us is better visualized in a graph format like this, but actually enabling it in a much easier to use format for code. So if you want to get the result of a graph out and actually be able to use that inside your application, as Misha said earlier, whether that's a kind of file list display or some page hierarchical nested pages in something like Notion, effectively that makes it much easier to work with in your code. But visualizing it, always easier as a graph.
I think we can make this even easier to look at, because cool thing about the graph view is you can configure a label, and on that label you can, for example, configure that to be the title. So for person, I think you can put it like to be title. And if you, Yeah, it shouldn't be uppercase actually. It's a little surrealist thing if you make it lowercase, because that's the
There
and
we
then just close the thing, I think. Then now we should, there we go. We can now very easily see VP, CEO, and see what role that person is.
Yeah.
Yeah, exactly. And then we have kind of some analysis we can do on this. So here we have, again, just finding the CEO, putting that in variable. And then we're doing this query where for each person, we're essentially give us the shortest path to the CEO. And this can be this is of course like a very simplistic example for the purposes of the stream. And we have a blog that our colleague wrote that kind of dives more into the visualization aspect of it. But what we do when we kind of run this query, we can now see for each person the kind of like shortest path to that CEO. And that's kind of like through this person, then you can go through this person, and like for manager. And as you can see, because we have just simple hierarchies, for a manager, there will always be 2 people. For an employee, there will always be 3 people. And for the CEO, like there will be nothing, because the CEO is, of course, the CEO and doesn't need to be recursed. And interestingly enough, here you can actually see that this data to some extent makes sense, because if you go now to the graph view, and let's select the query, you'll actually see that it looks exactly like the other query, because we're doing it for every employee. But if we were to select a specific person, then you would essentially see a different result. So let me just go here and select just one person, run the query, and then go back to the graph view. You can essentially just see this specific result.
That's interesting. So we've jumped into now shortest path calculation, going back up to the CEO. And that brings us to the topic of computing the actual path, but also the shortest path. Because it's not just about shortest path, is it? It's about the path by which the path to this the end of this query, let's put it that way, this relationship, what does it look like? How have we got here? And how can we work our way back? So this is incredibly important for whether it's for training AI models, whether it's for analyzing connections to people in defense, whether it's analyzing fraud, trying to work out the connections between different people or different activities or different objects like an ATM and a bank and things like that. This is where shortest path calculation and the analysis of graph and being able to analyze the most optimum route or the shortest route between 2 objects becomes incredibly important in analyzing your data. Now, without forcing you to have to use data in a graph-like way, in Surreal you can bring your data stored in a document-like way. You can analyze it in a document-like way. You can use vector indexes and full-text search to query and analyze your data. And then you can add these relationships in between that data and properly understand how those relationships and how those records relate to one another. Misha, I know you had some examples on the shortest path. Should we share your screen?
Let's go. So let's first of all populate some data again. So for paths, so we'll have a person U, we'll have some friends, some acquaintances, and we'll have a star. We can relate all of these people that they know each other. That's just what the data is for these examples. So from person U, we can recurse to an infinite depth, and something new compared to the previous queries is that we can actually provide options to how we want this recursion to act, to behave as well. So we'll collect a path for all of these sort of relations that will traverse, and this is for every person. Will basically get the people who they know. If we were to execute this query, we can see we skip the first node in these queries. Actually, we'll come back to that later. But we'll go from person U to friend 2 to acquaintance 1, from friend 2 to acquaintance 2, from friend2 to acquaintance2 to star, and we'll get all of these paths basically. And then secondly, we also have a shortest path option. This is what Alex just showcased earlier as well. So we can find the shortest path between you and person star, which is via friend2, acquaintance3, and then into star. We can also collect all individual values that we encounter. So what this will do is, we previously had all of these paths. We get a lot of duplicate data here. We can also just collect all of the unique nodes that we come by.
Now let's look at that solution in a little more detail. Effectively, this is looking at all of the different routes to that person. So from person U to person star, all the different possibilities.
Yeah, this is finding all the different graph paths that there are between the nodes
and putting it into one large collection of paths.
Yeah.
So it's not saying that these are all the nodes we've tried. It's saying these are all the nodes we've tried, and which form a path to the final destination.
Yeah, that's correct. Yeah. Yep.
I was going to say it's important because a query like that can be used as a starting point for another query to then work your way out to other relationships.
Yeah, exactly. One last option, which I said here that the starting node is missing. If you want that node in there, it's quite easy. You can just specify plus inclusive as well, and now we'll get the starting node as well for all of these queries.
So then in your application, you can build this up in whichever way you want to be able to analyze the total path from a source to a destination, and then also to work out in those intermediary steps what are other relationships that we can find. So potentially, if you found, let's say, and fraud has happened over here, and this is the relationship that we've detected that fraud is happening, how can I then, on the intermediary steps between, work my way out to other potential things or that are going on, things that shouldn't be happening that are going on.
Indeed, yeah. And I think one important note about shortest path here right now is it will basically just find the shortest path when it comes to the relations. You cannot really compute any weight there. Though I think having a weight option here as well, which allows you to sort of specify some sort of weight, could be quite cool. Could be a nice addition, because then you can actually solve the traveling sales problem as well, I think.
So yeah, we don't have that yet, but that's something we've been thinking about, definitely. Let me just jump into the community questions again. So so interesting point from Marius. This is definitely, so if you haven't already, do jump into Surrealist, into the cloud side, into the cloud, and you can access Sidekick, which has a much better understanding of SurrealQL. But we're looking at other ways of improving our documentation and the help and advice that we can, in an automated way, give you about the query language, about its possibilities. As you can see from just this 45-minute stream so far, but the possibilities of what you can do with SurrealQL are limitless almost. It's always fun to see internally and externally some incredibly complex, albeit with a simple query, example that users are able to come up with, which does some amazing data generation or linking between data points. And do definitely jump into our university and into the Surreal book, Aeon's Surreal Renaissance, I think. And have a look at some of the examples, because they start basic, but they really walk you through the best way of getting to grips with some of the more advanced queries. So definitely take a look at that as well. But yeah, if you're not using Sidekick already, definitely jump in and use Sidekick. It's completely free. You can ask it any questions. It answers as best as it can. It's still an LLM about SurrealQL, about the docs, about any questions you have about SurrealDB.
Yep. On that note, we also included kind of like a LLM.txt for better parsing of the docs. So that's something that you can also experiment with.
Yeah, definitely. Edonius, thank you. just going to pull this one up here. Leading the DB game. That's what we like to hear. Glad you like it. Glad you like it. We're working on some amazing things as well. So always got some exciting stuff in store for you. Jason, great to have you with us today. Do you have any sort of community detection examples, thinking in particular for graph RAG type applications? We can definitely, if we don't have any examples right now, we can definitely have a play around and create something like that. We're working on some great graph RAG examples anyway. I'm not sure about community detection exactly, but we're definitely working on some graph RAG updates with this new functionality, and we should be hopefully publishing that soon. So yeah, if not there already, we'll work on that, and we'll be pushing it to the blog, to the community soon. So it's many of our users are using the graph-like functionality alongside vector search and RAG effectively, and bringing in the results of LLM text generation or understanding into their applications. That's definitely a big one for us. No, Haribar, no, you don't have to make a new instance of Surreal Cloud. You can just jump in. As long as you're running in Surreal Cloud, you don't have to have an instance. You can use Sidekick in there, in the interface, in Surrealist. So we've got an interesting question from Entertain. So how do graph queries perform at scale? So this is an interesting question. We recently performed benchmark results of SurrealDB, but we haven't yet done or included in those results benchmarking for graph queries, purely because there's a lot to do in order before we get to that point. So we're adding into our benchmarking tool, we're adding in multi-request transactions, so a transaction that can do multiple requests. We're adding in improved scan support in the benchmarking tool. We're adding in filtering and indexing. After that, we'll also be adding in the support, the ability to run and compare graph queries. So graph queries, obviously, there's always a cost depending on what type of graph relationship you're doing. So you could be doing a record reference, which will be simpler, fewer writes on the disk or on the storage engine. Or you could be doing a full-on graph relationship, which is more complicated. There's more stored in the storage engine, but obviously gives you much more possibilities, especially when it comes to storing metadata about your relationship. So but it's going to have more cost with it. But in terms of how graph relationships scale, effectively SurrealDB is the biggest differentiator between SurrealDB and other databases is these record links, the record IDs. And these enable you to jump directly to a particular record on a table without any indexing. Now, with that basis, we're then able to build on top and add in time series-like functionality or graph-like functionality, where when we traverse across a set of relationships, as we've been doing in the examples today, we're effectively just jumping in an O1 complexity way. We're jumping directly to records in a table. We don't have to be doing table scans. We don't have to be doing indexes at all. All of the graph functionality we've shown you today can operate completely without indexes and can traverse whether there is one row in the table or millions of rows in the table, as it just jumps between those rows, those tables. So effectively, graph relationships can definitely scale. We'll be adding those to the benchmark tool and releasing those as soon as we get around to doing that. And in addition, as you know, the separation of storage and compute in SurrealDB enables that to happen locally, vertically scaled up in a single instance, or in a fault-tolerant, highly available, highly scalable distributed cluster, which enables you to scale out the amount of data you're storing. So that brings us to the end of the stream. I think we've covered everything. Is there anything we've missed, Alex, Misha?
No, I think that's kind of like primarily it. The one thing we perhaps haven't covered is kind of like the functionality we have is kind of like the core functionality and kind of like a key things and the primitives you need to build more complicated things. There might be kind of like specific graph kind of like algorithms like for community detection and other things that have not yet been implemented, but we're definitely looking into kind of like expanding our use cases.
Definitely.
And I think most importantly, everything we've shown today can be completely run as Surrealist, which can be accessed from the browser. It just runs inside the browser there, the whole SurrealDB. You can try the graph in there. You can try it via SurrealDB University, via the docs. There are some examples in there as well, and we'd love to hear what you think.
Definitely. A couple more questions coming in now. So ask me anything to everything. You can ask any questions on here. We do answer everything as possible, albeit the stream is definitely got a specific topic. Omar, good question. So is it possible to create a cluster with self-hosted instances? Absolutely. Go away, build a petabyte scale cluster and tell us what you're building on it. We'd love to hear about that.
Yeah, it's just about storage engine. So you would be using TiKV for that.
Absolutely. So we've got another question here. Will you be adding a feature like PG cron in the future? We've actually discussed this internally, haven't we? So cron-like functionality and being able to define events which happen or triggers which happen at a periodic interval is definitely something we want to add. Now, in SurrealDB, we have to think about how things work in an embedded use case. Very easy to add cron-like events there. In a single node instance, very easy to add cron-like events there. And in a distributed instance, which can scale to 30, 40, 50 nodes. Now that becomes a lot more complex. You now have to think about distributed algorithms, about workers, which, are there multiple workers running? Are the workers able to cope with the amount of demand of the cron? Which one is the leader? Which one is the follower? All of these different things you have to think about in a multi-node context. So everything that we build into Surreal has to work across those different deployment options. And as a result, yes, we definitely want to build in PG cron-like functionality in the future. We just got to work out how we do it in the best possible way in a distributed environment.
I believe there might be an issue actually on GitHub, which you can track if you're interested in getting updates for that.
Awesome. Yeah. So jump into GitHub, into our issues, and definitely search for the cron feature. I'm sure that exists, and subscribe to that if you're interested. So we've got an interesting question here. So is SurrealDB Cloud optimized for SurrealDB over and beyond something like just running it on a VPS? We definitely do things that optimize it in a slightly improved way over a traditional VPS. I think that's definitely something that is kind of expected of our cloud. I think importantly though, there are lots of things security-wise that go into making sure that our instances are completely protected, that they're isolated, and things like that. So it's about the management of it. I think the other main point is it's super integrated into Surrealist. It's very simple. We've got an update coming soon, which we're really pleased about, which integrates it even more, brings you more information, more statistics around your instances. So it's more about the integration into the different ecosystem, the ecosystem of SurrealDB as a whole. But yeah, there's obviously lots of things that we do optimize specifically. That's not to say you can't optimize it yourself. There's lots of different ways of optimizing and configuring SurrealDB to work for you. It's about working out which ones work best for the environment you're running. And got a lot of questions coming in the last few minutes. So, what are your standards for contributing? It's an interesting question. I mean, we accept PRs, which we love. Let's put it that way. If we like the PR and it works from a security perspective, from a functionality perspective, it usually does get accepted. Now, let's say it has to work in the different ways that SurrealDB can be deployed. It has to work from a security perspective. Obviously, performance is becoming more and more of a consideration for SurrealDB as we scale up the projects in which it's being used. But yeah, definitely, if you've got an idea, I'd say first of all, jump on Discord, have a chat with some of our engineers if there's a particular idea you want to work on, or if you've been working on, and share that with us and before starting any large work. But yeah, definitely, if you've got a PR you've already done, share it and we can discuss it. But thank you for that point. We'll improve the contributing file a little bit more. So we've got one final question here from Entertain. Can graph queries work across horizontally distributed nodes? I think it's maybe TiKV engine. Absolutely. There is no limitation, Entertain, with how you can query data when you scale up the storage engine. So the storage engine is effectively just something that you have to scale, or you can scale, but the queries that you run on top, and that's really important, the queries that you run on top do not differ whether you're running on a distributed network or on a single node instance, or even on an embedded deployment. So yeah, absolutely no difference between TypeKV for graphs and between RocksDB for graphs. That kind of brings us to the end of the discussion today. It's been almost an hour. It's been great to answer your questions. Thank you for all of those amazing questions. For any other Ask Me Anything like questions, if you want to jump into Discord, we have a regular Discord AMA where I answer any questions about anything that you want to ask. Hopefully, if we keep it to SurrealDB, that'd be good. And in our next stream, which will be in April, I'm not sure the date off the top of my head, but in April, we'll be looking at the graph visualization tools in Surrealist. These have been an amazing new feature at the beginning of this year, which enables you to visualize your data. We touched on it a little bit today, but in a much more kind of improved way that enable you to get better insights around the data that you're storing in SurrealDB. So hopefully join us again in April, and we'll be back on sharing the Surrealist updates. But in the meantime, thank you for joining us. Alex, Misha, thank you for walking us through the example queries. And everyone online, good night, good evening, good morning, wherever you are. Take care, see you soon.